Hello everyone, my name is Dr. Omar Coker and I welcome you all to another exciting video of networking class and information security course. In this video, we will be talking about IPv4, IP addressing, very important topic. If you really want to understand cybersecurity, ethical hacking, penetration testing, you have to have a good understanding of IP addresses. So in this video, we will have a detailed understanding of IPv4, what exactly the IP address is. We will discuss NAT, network address translation. We will discuss PAT. We will discuss private IP addressing, what exactly the private IP addresses are. So mainly we will focus on these particular topics. So let's start with the IP address. So first of all, let's start with what is IP address. So IP address is basically a name of computer over internet. So you can simply say a name of computer over internet. So computers, they typically have two type of names. So computer can have two type of name. A name can be physical. It can be a physical address, or a computer can have a logical address. So this physical address, when we talk about physical address, we are basically talking about network interface card. For example, the Wi-Fi network interface card, or for example, the Ethernet interface card. This is like fixed, you cannot change it. Logical address is basically the one which we are talking about, IP address. And now this IP address can be from IPv4 or it can be from IPv6, right? Our focus is going to be IPv4. The length of IPv4 address is 32 bits. You might have seen IPv4 addresses. IPv6 is mainly 128 bits. Typically, this is the one which ultimately we're going to use. But right now, most of the servers, most of the system, they use IPv4. They do use IPv6. There is a transition method, but we will discuss it in another video. So in this video, we're going to focus on IPv4, what exactly the IPv4 is, how it looks like, etc. So typically IPv4, as I mentioned, the length of IPv4 is 32 bits. And this is how it looks like. It has mainly 4 octets. Four octets mean it has 4 main parts and each particular part is of 88 bits, right? So it has 88 bits. Each part is 88 bits. And how many different possibilities are, like what I'm trying to say is, like for example, if you see, look at each particular segment, it is made of 8 bits. So for example, it can be 0000000, all 4 8 zeros, or it could be 7 zeros and there is 1 on side. And how many different possibilities will be, like there is a possibility where all the 8 values are 1, sorry. So if you calculate the decimal value of this, like all zeros, decimal value is 0, this is 1, and up to 255. So what does it mean? It means every octet has value ranges from 0 to 255. How do we calculate it? You know that 1, 2, 4, 8, 16, 32, 64, 128. I'm not going to go in that detail, but I'm pretty much sure you already know how to convert a binary into decimal. So for example, I want to calculate the decimal value for 1. So all of them would be 0. This should be 1. Got it? This is the binary value for 1. And for example, if you want to calculate the binary value for, let's say, 192. So you know that 192, you just have to use these numbers. So let's say 128 plus 64. So 128 plus 64, it is going to be 188. Well, yeah, this is 192. Then all will be 0. Are you getting a point? So the value from in each octet ranges from 0 to 255. So it can be any value from 0 to 255, right? So this is how it looks like. And IP address has 2 main parts. So IP address typically depicts 2 main things. It depicts network ID, which is unchangeable, and it basically defines the organization's ID. And second is called host ID. Host ID is basically the one which we can assign to client's computer, and this is something which is fixed. You cannot change it. This is the ID of the organization who owns that static IP address. So next is the class of IP addresses. Like whenever you are given IP address, how you can find out how many IP addresses I can generate, like how many computers I can support, and what would be the rules of different particular IP addresses. So mainly there are 5 different classes of IP addresses: class A, class B, class C, class D, and class E. So these are different classes of IP addresses. So for example, if you see the IP addresses As I mentioned earlier, it has 4 octets. If, for example, the first octet, as you know, the value can be 0 to 255. If the first octet value ranges from anywhere from 0, in fact 1, I don't say 0, it's 1 to 126. If it ranges from 1 to 126, that IP address belongs to class A IP address. If it ranges from 128 to 191, so it means it the first octet again, not the second octet. So it means the IP address belongs to class B. If it is 192 to 223, then IP address belongs to class C. Similarly, 224 to 239 belongs to class D, and 240 to 255 belongs to class E. For addressing point of view, we don't use the last two, D and E. Like D is typically used for multicasting. No, you can ask a question like, what is multicasting? For example, different vendors, if they want to do the multicasting to their devices, like sending updates, these sort of things, so they use the IP address in this particular domain. And this is dedicated for research purposes. So these two classes are reserved, and we don't typically use these particular classes for IP addressing. So typically we use either class A, B, or C for IP addressing. Now, it depends the size of organization. So you can pick up the IP address, you can find, or you can, for example, purchase IP address. Depends upon the size of your organization, how many computers you want to support. For example, class A IP address. So in class A IP address, as I mentioned, we have 4 main octets. So the first octet is reserved for network part, and remaining are available for host part. It means these are variable, but this is fixed. I'm going to show you in a bit. Similarly, class B, the first 2 octets are reserved. The last 2 octets are available for host. So what does it mean? The first 2 octets are basically the network ID. Class C, the first 3 octets are reserved for network ID, network ID, network ID, network ID, and only last octet is available for host part. So how many different IP addresses we can generate? So please remember, network ID is fixed, name of organization. It is fixed, you cannot change it. You have 2 power 8 possibilities here, 2 power 8 here, 2 power 8 here. So which is equal to 2 power 24. So 256, 256, 256 here. It is approximately 16 million. So 16 million IP addresses, the dedicated individual distinct IP addresses we can generate. Here, these 2 octets are reserved for network. We cannot change it. It is the IP address of your host, the network. So we have 2 power 16 IP addresses available, which is approximately 65,000 IP addresses. Last but not the least is the small network. If you have a very small network, you have only last octet available, which is 2 power 8. So which is 256 IP addresses can be generated. So class A IP addresses are typically used for large networks, corporate sectors, the large network. Class B IP addresses are typically used for middle-sized organization, for example, enterprises, for example, colleges, universities, they use that. The last class C IP addresses, it is like a household network, like a small network where we have maximum 256 possible computers or 256 possible devices. So we typically use a class C IP address. So next thing which I would like to share here, which is regarding the classes, and that particular term is called subnet mask. Now, subnet mask, why do we use it and how exactly it used? Subnet mask basically differentiates an network ID or network part from the host part, and network bits are basically represented with 1, host bits are represented as 0. So yeah, that's very, very important. So you need to remember, network bit will be 1, host bit will be 0. So for example, if you are given this IP address 192.168.10.10, now the question is, first of all, tell me what type of IP address it is, class A, B, or C. So you need to tell the class of this IP address. What is the class of this IP address? We know that the first octet 192, where it falls, we know that it falls somewhere right here, 192, right? Class C. So this is a class C IP address. We know that it is a class C IP address. Now, if you want to find out what is the network part, you know that the first 3 octet, this is network part, this is network part, last one is available for the host. So network part, as I mentioned earlier, it is represented with 1. So how long it is? 8 bits, right? 8 bits. So what we're going to do is, 8 bit. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. And host bits 0. All zeros. 8 zeros. All right. Now what would be one more? Okay, so what would be the decimal value? You just have to calculate the decimal value of it, like 1 2 4 8 16 32 64 128. If you calculate it, it's going to be 255. 255.255.0. This is basically the subnet mask for any class C IP address. Now, for example, let's take another example. Let's say you are given this IP address 10.10.11.11, and you have been asked, tell me the class of this IP address. So you're going to look the first octet, check out the ranges. You know these ranges. You know it belongs from class A, from 1 to 126. It falls somewhere right here. So I am going to call him a class A IP address. So this is a class A IP address. Now, as you know, in the class A IP address, first octet is reserved for network. Remaining octets are available for the host part. We know that. So what we are going to do, we are going to, for network part, all ones. Remember, network part all ones. So what does it mean? 255.0.0.0. So this tells this is the network part, remaining are available for the host part. Got it? Now from here, I'm going to tell you one more thing, which is called network ID. Network ID. And there is one more, which is called broadcast ID. So broadcast ID or network ID, what is the difference? So first IP address in that particular range is called network ID. For example, now let's say this, you find this IP address 10.10.11.11. You know that this is a class A IP address. You know that the subnet mask, but you need to find out what is the network ID, because this IP address belongs to a certain computer. What does it mean? It means there might be a very large network and there are millions of computers, and this is, for example, the DHCP server, dynamic host configuration protocol server, who assigns the IP addresses whenever some computer requests for IP address. So what would be the IP address which they have purchased or from where they have started? So that is called network ID. And how do you find out? The first IP address in that range. So the network part will never get changed. Remaining host part will always be represented with 0. So network part is 10. Remaining part are 0.0.0, just like right here. But here in the subnet mask, we just make it all ones. But in network ID, we just keep the same value, whatever the value is right here. I'll give you some more examples. Broadcast ID is basically the ID which typically administrator they use in order to send a ping packet to all the network, or you want to test out, or you want to send a message to all the computers on your network. So what you're going to do? So 10.255.255.255, like last IP addresses. So these two IP addresses are reserved network ID, broadcast ID. We don't assign it to any computer who is requesting for IP address. The usable IP address would be 10.1.0.0, 10.2.0.0, etc. up till right here. So remaining between these IP addresses can be usable, and these two IP addresses are reserved for network ID, the ID of the host, your network, and broadcast ID is if you want to send a broadcast packet to overall computers. Let me give you one more example so you can better understand it. So for example, if you have IP address, let's say 172.168.20.90. If you have this particular IP address, then what's going to happen? If this is your IP address, first of all, you need to find out the class of this IP address. You know that 172, where it falls somewhere right here up till 98. So it's right here. So it is class B IP address. Class B IP address mean the first two octets are reserved for host part and last two octets are available for network part. Got it? Now, subnet mask. If you want to calculate the subnet mask, you already know that network ID 255.255.0.0. If you want to find out the network ID will keep the network part same as it is, whatever the IP address is. So it is 172.168.0.0. But when it comes to broadcast ID, it is going to be the last IP address 172.168. It can be maximum value 255.255, and IP addresses which can be assigned to host will be between these. I hope it clarifies the concept of class A, B, C, and what is subnet mask, how to calculate the network ID, how to calculate the broadcast ID. Now I'm going to tell you there is a classless IP addresses. We will talk about it in a separate video. I don't want to make this video too long. We'll talk about it in another video. There is another term which is called private IP addresses. Private IP addresses. So private IP addressing. Private IP addressing is basically like because any device who wants to connect with internet, it needs IP address. But the problem with IPv4 is we don't have trillions of IP addresses. As you can see, from one class A IP address, we can generate 16 million IP addresses. So we have a limited number of IP addresses left. So we cannot have the trillions of IP addresses for all the devices. Like if you have a smartwatch connected with internet, it needs the IP address. If, for example, you have a cell phone, it needs the IP address. So we don't have trillions of IP addresses. So what is the bottom line? We came up with the idea of reusing of IP addresses, and we reserved some ranges where IP addresses can be used like different. Like for example, we have one campus of college here. Let's say this is your campus, for example, University of Georgia. And this is, for example, Georgia Tech. So Georgia Tech, whatever internally the IP addresses they can use, Georgia Tech can also use the internal IP address. And they just need one public IP address. So public IP address is required for communication over internet. So public IP addresses can be communicated with public IP addresses. Private IP addresses are basically used within the local area network. Nobody knows the private IP addresses outside the local area network. So private IP addresses are just like, for example, if I have a hotel here, let's say Holiday Inn in, for example, New York. Another Holiday Inn is, for example, in, let's say, California. So Holiday Inn can have numbering, let's say room number 1, room number 2, room number 3. California Holiday Inn can also have 1, 2, 3, right? But their public address is different. Internally, they can have the same numbers. Exactly the same way we implement the networking model here. So private IP addresses ranges for class A. So for class A, we have reserved 10.0.0.0 all the way to 10.255.255.255. So for example, if you type a command ifconfig or ipconfig in your Windows computer or in Linux ifconfig, you will see your IP address 10 dot something. It means you are using a private IP address. So class B, 172.16.0.0 all the way to 172.31.255.255. All right. So this is basically the range for class B IP addresses. Class B IP addressing. Similarly, for class C IP addressing, we have the range 192.168.0.0 to 192.168.255.255. This is basically the private addressing ranging that we have. So let me just make you understand with the concept how this private IP addresses are actually used, how we do the implementation of this. So to understand it, let me introduce you the concept of NAT. The concept of NAT. And NAT stands for Network Address Translation. So network address translation, what exactly network address translation does? It basically allows or convert public IP address. So it basically translates a public IP address into a private and otherwise, and private into public. All right, let's try to understand the phenomena. So for example, this is my local area network. In my local area network, let's say I have 3 computers. All right, I got 3 computers, and this is, for example, my router on which I'm also implementing NAT. And let's say this is connected with the internet. And I have, for example, a couple of websites. Let's say this is facebook.com. This is, for example, Google. And for example, Amazon. Facebook IP address is 1.1.1.1. Google is 8.8.8.8. And Amazon is, let's say, 10.10. Not 10. 10 is, of course, a private. So let's say 9.9.9.9. All right. So within my local area network, so let's say this is my local area network. So for example, your organization has assigned an IP address something like 25.1.1.1. All right, this is public IP address, class A. Within your local area network, I have assigned this computer IP address, let's say 10.1.1.1, 10.1.1.2, 10.1.1.3. So these three IP addresses, and my NAT router gateway, internally it uses 10.1.1.4. And public, this is my public IP address. Now, as I told you guys, internally we can use private IP addresses, but nobody recognizes 10.1.1 over internet. Nobody knows that, because this is, for example, GGC, Georgia Gwinnett College. UGA might have the same IP addresses. They might have the same IP addresses. So how it's going to happen? So let's say if this computer 10.1.1.1 wants to access facebook.com, it wants to access Facebook 1.1.1.1. This request will go to your NAT device. NAT device will update a NAT table like here, like this table, and it will put here, okay, my private IP address was 10.1.1.1 wants to access, let's say, facebook.com, which is 1.1.1.1. So this is public IP address which they are trying to access. So what's going to happen? Your router or your NAT device will forward the request on your behalf, right? So Facebook will get to see that request came from 25.1.1.1 rather than 10.1.1.1. So let me repeat. You will request to your NAT device will put it inside the NAT table, and then it will convert it or use its own public IP address and make a request on your behalf. When Facebook receive it, Facebook will respond back to your public IP address, not to you. And when your NAT will receive it, NAT's going to see that, okay, who was talking to 1.1.1? Okay, 10.1.1.1, it's going to forward the response back to it. So for example, if this is another computer, 10.1.1.3, if it wants to talk to amazon.com, so again, it will forward request 9.9.9.9 to NAT device. NAT device will use its public IP address, forward 9.9.9, put it in the NAT table, forward the request from its public address, which is 25.1.1.1 to amazon.com. When Amazon will receive this response, so Amazon will receive the response, Amazon is going to forward back to, Amazon will forward back it to your public IP address, which is your NAT device IP address, and NAT knows who was talking to amazon.com 10.1.1.3 and forward the response back to it. Now, when the problem will come, the problem is going to be, for example, let me make it simple. So let's say I have two computers here, A and B, and IP address, public IP address is, let's say, for example, 25.1.1.1, and this is 10.0.0.1, 10.0.0.2, and the public IP, private IP address is 3, for example. This is 3, 10.0.0.3. And they are talking to, for example, google.com. Both of them are talking to google.com, which is 8.8.8.8. So in this example, if both of the computers simultaneously wants to reach out to google.com, now what's going to happen? Like if we use the same table, like this computer 10.0.0.1, which is the private, was talking to public, which public? 8.8.8.8, and this computer 10.0.0.2 is talking also to 8.8.8. So when Google will respond back, so then your NAT device is going to get confused where to forward the response. In that particular scenario, we extend the NAT, and the term PAT came in, port address translation, where we also assign a public and private port numbers as well. So a public port number, and a private port number. So what I'm trying to say, what's going to happen if this computer 10.0.0.1 wants to talk to google.com? So what's going to happen? 10.0.0.1 port number, let's say 1000, wants to talk to google.com, and let's say NAT will use 25.1.1.1, and let's say port number 3002 for this one. All right, so I'm going to put it here. My 3000 port was talking to this, and private port was 1000 on that. Similarly, for this particular computer, I'm going to use 10.0.0.2 port number, for example, 1001, and for communication 25.1.1.1 to port number 3003, something like that. Now, whenever the response will come, this is going to be 1001, 3003. So whenever they will respond back. So we'll see that on which particular port response comes, so we can forward accordingly. This is basically called paired. We just add the port numbers so we don't mix up the data. I hope you guys understand the basic concept of networking. If there would be any question, please feel free to let me know. Just drop a comment. We will also discuss the classless IP addresses if you really want it. So please put it in comment. We can discuss that. I'll try to give you as simple example as possible.